Welcome to QUIKPORT XP. This tutorial will show how simply and quickly portals can be created using Input Wizard. The tutorial is divided into 4 parts. This is part 1. To run Input Wizard, we click on this button. This is the introductory form. To move forward, I click Next. Let's create a new project. I'll call the project Video, why not, and I'll enter a title. We'll move to the next form by clicking Next. This is the Input Wizard Bays form, and this form will enter the dimensions down the side of the building. Well, the first bay will be 6 meters, and then I'll have 5 bays at again 6 meters, and then for the end bay 6 meters, and we'll do a 2-span portal. Next, this is the Input Wizard Spans form. These buttons are for the basic forms of portal. We'll leave dual pitch selected, and we'll enter a pitch of 12 degrees. We'll have an eaves height of 5 meters, a base level of minus 0.5, and the same on the other side, minus 0.5, and we'll use a span of 20. And we'll make both spans the same by clicking on Apply to All. Apply these details to all spans. Yes. Here's span 1 and here's span 2. Click the Next button. This is the bases form. Currently all bases are set as nominal pins. This is base 1, base 2, base 3. I'm quite happy with that, so I click Next. And this is the haunches form. We have haunch 1, haunch 2, haunch 3 and haunch 4. And currently they're all set to have a length which is 10% of the span and a depth which is set to use best depth. And that concludes part 1 of this tutorial. Welcome to the second part of the Input Wizard tutorial. In the first part we entered the basic geometry, bases and haunches. Now let's add the purlins and rails. Click on the Next button. This is the purlins form. This is a list of the purlin centers. Currently there are no purlins. We could type them all in by selecting Insert Before on the pop-up menu. But QUIKPORT has a simpler method. We'll click on the Auto button. This is the Input Wizard Purlins Auto form. It says here all purlin dimensions are measured from the apex. The first center is currently 0.3, then 2 at 1.5, and then the remainder at 1.8 meter centers. I'm happy with that, so I'll click the Next button, and I'll apply these to all rafters and select Finish. And this is our final rafter with its purlins. Rafter 1, rafter 2, rafter 3. And we've got this little diagram here that tells us which raft is being displayed. So that's the purlins done. I'll click on the Next button. And this is the rails form. I'll proceed in a similar manner. I'll click on the Auto button. But this time all rail dimensions are measured from the column base. I'll have a first center of 0.65. That's the half a meter to the base plus 1.5 for a bit of clearance. Then I'll have 2 at 1.5 and then the remainder at 1.5 meters centers. It's actually remembered these defaults from when I did this just now. I'll click on the Next button. and I want to apply these rails to just the first column and the last column. That's missing out the valley column. And I'll select finish. So this is our first column, the valley column, and the right hand column. And that concludes part 2 of our Input Wizard tutorial. Welcome to part 3 of QUIKPORT's Input Wizard tutorial. In parts 1 and 2 we input the basic geometry, purlins and rails. In part 3 we'll move on to the roof loads and the wind loads. We'll click next. These are the roof loads which will be applied to our building. This is a default set which applies to many portal frames. We can however change them by right clicking and selecting change on the menu and altering the values here. I'm going to use the default, so I click cancel, and I'm going to leave it selected that the program should automatically include the self weight of rafters and columns. I'm going to click next, and now we'll look at the snow loads. The site location we'll say is in Poole. The altitude we'll put at 12 meters, and the basic snow load for Poole is 0.4 kilonewtons per meter squared. We can now immediately look at the calculations. They're in accordance to 6399 part 3 1988. If we scroll down we can see that these snow loads 0.23 kilonewtons per meter squared fall well below the imposed load, so I've decided not to consider snow loading. Click next. Now we'll look at the wind speed. We'll apply the wind loads. It's BS 6399 part 2 and we're using the standard method. Site location is in Poole. The altitude 12 meters. The basic wind speed for Poole is in fact 22, it's already set meters per second. The effective building height has been picked up from the geometry of the frame. Closest distance to sea 2 kilometers, and we'll leave the site in country terrain. Now let's view the wind speed calculations. If we scroll to the bottom we can see a dynamic pressure of 0.87 kilonewtons per meter squared. I'll close this form and click on the next button. Now this form lists all the surfaces around our building, and as we click we can see the surfaces being highlighted in the 3D visualization above. And this table lists all the calculations right along until we get to the final pressure coefficient. Indeed, we can view a report which shows all these surfaces and pressures. We could change this table by clicking and selecting from this pop-up. This is for the wind direction of 0 degrees, 180 degrees and 90. And we can look at the view of the building from different directions. We can even spin it. Okay, that concludes part 3 of our tutorial. Welcome to the final part of the Input Wizard tutorial. In part 3 we looked at the wind loadings and the wind coefficients. Let's click next. The prompt says not all values of CPI have been entered. Are the defaults correct? I'm going to confirm yes. Okay, this is the Input Wizard deflection limits form. These are the limits for span 1 and span 2. And these default limits impose a limit horizontally of 20 millimeters at the eaves and 100 millimeters at the apex. We can change these values by right clicking and selecting on the pop-up. We can put a variety of different deflection limits in. I'm going to work with the default, so I'm going to hit cancel and then next. The program is now producing all the different frame files along the length of the building, and because of the nature of the wind loading, the uplift is different on the gable frame than on the first portal frame. So we have to select which file we think is going to be the most onerous, and currently I'm going to confirm the program suggestion of frame 2, which has the higher wind uplift. I'll select finish, and QUIKPORT has now opened that frame and put it in its main window. And that concludes the Input Wizard tutorial.